The universe was never calm. James Webb just broke cosmology. Hello, everyone. And pay close attention to this because something unexpected is happening. For decades, scientists believed the early universe was slow, simple, and quiet. Small galaxies forming gradually, stars taking their time, structure building step by step. But in 2022, everything changed. The James Webb Space Telescope began looking deeper than ever before, and what it found didn't match reality as we understood it. Instead of a calm beginning, the universe looked fast, chaotic, and unbelievably efficient. Friends, this might surprise you. The early universe may have broken the rules we thought were unbreakable. Stay with me, because what comes next gets even more interesting. Telescope designed to see the impossible. To understand the discovery, we first need to understand the tool behind it. The James Webb Space Telescope is not just a better version of Hubble. It's a completely different machine designed to answer a different question. What did the very first galaxies look like? Here's what makes it revolutionary. A 6.5-meter mirror, made of 18 gold-coated segments, about 5 times more light collection than Hubble's sensitivity to infrared light. Not just visible light, and this is the key. Because of something called redshift, light from the earliest galaxies is stretched as the universe expands. What started as visible light billions of years ago arrives today as infrared radiation. That means older telescopes simply couldn't see it. We were looking at the universe, but missing its earliest chapter. JWST changed that instantly. Within weeks of operation, it captured galaxies whose light had been traveling for over 13 billion years. That's when things started to get strange. Keep watching, because this is where it gets interesting. Galaxies that should not exist according to the standard cosmological model. Early galaxies should have been small, dim, slowly forming, but JWST revealed something completely different. Scientists found galaxies that were massive, comparable to the Milky Way, bright, and structured, formed within just 300 to 500 million years after the Big Bang. Let's pause for a second. Under normal physics, galaxies convert only about 5 to 10% of their gas into stars over long periods of time. But these early galaxies appear to have converted nearly all available gas into stars almost immediately. That level of efficiency isn't just unusual, it's nearly impossible. Even more surprising, bright galaxies in the early universe are about 10 times more common than predicted. Some show complex structures, not primitive form. Scientists expected a slow buildup. Instead, they're seeing something closer to a cosmic explosion of structure. What do you think about this? Does this change your understanding of how the universe began? Because researchers are now asking a serious question. Is our entire model of galaxy formation incomplete? Oxygen appearing too early? Now things get even more surprising. One of the most important discoveries made by JWST was the detection of oxygen in a galaxy just 290 million years after the Big Bang. To put it simply, this should not be possible. Here's why. The Big Bang produced mostly hydrogen and helium-heavier elements like oxygen are created inside stars. Those stars must live, die, and explode to release these elements, so detecting oxygen means something very specific. Multiple generations of stars had already lived and died. Let's break that down. First stars form, they live for millions of years, they explode. As supernovae, they enrich surrounding gas. New stars form with heavier elements. All of this within just 290 million years. That timeline is incredibly tight. According to previous models, star formation had barely started at that point. But the data shows something else entirely. The most interesting part of the topic is this. The universe wasn't just forming, it was already evolving rapidly. And that changes everything. Black holes growing too fast if early galaxies are. Surprising, black holes are even more extreme. In today's universe, black holes grow over time by pulling in matter. But this process has a limit, known as the Eddington limit, which prevents them from growing too quickly. Yet, JWST observations show black holes with millions to billions of solar masses existing just 400 to 500 million years after the Big Bang. That's not supposed to happen. Even more mysterious is a group of objects scientists call little red dots. These objects show something unprecedented. black holes making up 30% or more of their galaxy's mass normally. This number is about 0.1%. That's a difference of hundreds of times. Think about that. In some of these systems, the black hole is not just part of the galaxy. It dominates it. Scientists have proposed several explanations. Direct collapse black holes, forming without stars, superfast growth beyond known limits, primordial black holes for the early universe, but none of these fully explain what we're seeing. I'm really curious what you think. Would you trust a model that can't explain its own observations? Because right now, scientists don't have a clear answer. Crisis in cosmology, when we step back and look at all the discoveries together, a clear pattern emerges. The early universe was faster than expected, more efficient than expected, more complex than expected, more chaotic than expected, and this creates a real problem. Because the current model of the universe, known as lambda CDM, has been extremely successful for decades. It explains cosmic background radiation, large-scale, structured galaxy distribution, but now, JWST data is pushing it to its limits. Here's the core issue. The universe formed structures too quickly. To explain the observations, one of the following must be true. Star formation was dramatically more efficient. Dark matter behaves differently than we think, or the entire cosmological model needs revision, and none of these options are simple. Some researchers are trying to adjust existing theories. Others are exploring completely new physics. But right now, there's no consensus. And that's what makes this moment so important. We're not just discovering new things. We are questioning the foundation of modern cosmology. Conclusion: this is just the beginning. Before we wrap up, if this surprised you, don't forget to like and subscribe. It really helps support the channel. Friends, what we are witnessing right now is rare. Moments like this don't happen often in science. A new instrument appears, and suddenly, everything we thought we knew starts to shift. The James Webb Space Telescope has only been active for a short time, and already it has revealed galaxies that shouldn't exist, elements that shouldn't be there, black holes that shouldn't grow so fast. This is not just new data. This is a turning point. And the most exciting part? We are only at the beginning. There are deeper observations coming, more data being analyzed, and more surprises waiting. Thanks for watching. Stay tuned, because the universe still has many secrets to reveal. For more detailed content, talktendertech.com.